next example, example 2, is somewhat strange. So I want to bring our attention back to our list from the first video, solving exponential equations. Notice when we get it in this form before we start any of the other steps that our bases of the exponents don't have coefficients. So the first thing we have to do is get rid of the coefficients. So let's go to example 2. Notice how both of these sides have coefficients, and we don't want them there. We could divide both sides by 2, but then we'll still have a coefficient of 5. Or we could divide both sides by 10, and then we'll have a coefficient of 1/5. I'm going to show you how the coefficient of 5 is actually going to work, just because our base is 5. So we're going to be able to combine that together. So dividing everything by 2 is going to work much better than dividing everything by 10. Like I said, this is a little bit of a weird problem. I don't expect you will see things like this. So 2 divided by 2, that goes away, and that gives us 5 to the 3x minus 1, subtract 1, equals 5 times 25 to the x power. Well, we can go ahead and rewrite our 25 to the x power as 5 to the 2x power. So it's kind of like we have 5 to the first power times 5 to the 2x power. And when we have the same base with exponents multiplying together, we can just add the exponents. I know these are strange, but it works. Okay, so then over here, we still have our 5 to the 5x minus 1 power minus 1. Now I feel like that minus 1 is a mistake. I'm looking at my notes from this section, and in fact, it is a mistake. So we're going to take that out because I didn't know what to do with that. So the minus 1 was just there, and I thought I fixed it already on these notes, and I just made it somewhat worse. So we're taking that out, and that makes this much better. So now we have common bases on both sides. If we did have that 1 there, we would have to do something else tricky, like we would have to move this over there. We could do it. We could do that as a whole separate problem if you want, just for fun. Right now, though, we can just use our 1-to-1 property, where the 5's are the same, so we're going to ignore the 5's, and we're just going to set 5x minus 1 equals 1 plus 2x. We're going to get our x's together, so subtract our 2x over here, which gives us 3x, and add our 1 to both sides here, which gives us 2. And then divide both sides by 3, and voila, we have an answer for x. Just for fun though, what if this actually was right, and it actually was the other way with the typo that I hid in there? 5 to the x minus 3x minus 1, and then there was a minus 1 here, equals 5 to the 1 plus 2x. So what we can do, I'm trying to think if this would actually work. Can I move that to that side? I probably should have stopped while I was ahead, because I was thinking I could move that over there and combine them, but I can't because the exponents are different, so they're not like terms. So the way I was thinking of solving this wouldn't work out. I know there has to be a way to solve this, but that is way beyond what we are doing on this assignment. So I'm just going to stop trying to do that problem. So I'll take that out and save this video.